All right. Welcome, everybody, to today's Autodesk Community Conversation. This is the Autodesk Fusion 360 Masterclass from Zero to Hero with Praise Tom. He's an Autodesk technical specialist. I'll let him introduce himself here in just a minute. But I am your host. I'm Sean Hurley, Autodesk Community Engagement Manager. Welcome, everybody, for joining us. Nice little distribution. Next slide, please, Praise. There we go. Oh, we're missing one slide. Let me give you a quick, I'm going to combine two in one here. Community conversations are a webinar where we invite you to have a conversation, questions relevant to the topics. Today, we're going to have a lot of the questions at the end, but we cover everything from AEC, manufacturing, panel discussions. You can submit your own, all experience level sessions on the calendar. Today's is manufacturing. So now, before we begin, we made it so you can enable live transcription into 11 different languages. So if you want to hear this or read this in German, you can certainly do that by going to the more options and then turn on the live captions. If you want to give feedback to myself or Praise, you can hit the little Zoom reactions on the bottom, or you could just ignore it if they're not your cup of tea, and that's perfectly fine with me. You can raise your hand if you really want to be heard, or share your screen if you have something really important to share and relevant, but we're going to try and keep those to the end today. It does take quite a bit for us to raise you up from a panelist, but if we do get a situation where, it's usually with the Ask Me Anything, so we can go back and forth and understand what you might be seeing on your screen. You can use the chat for general comments, and you can use the Q&A panel to ask your questions. The session will be recorded, and the recording will be posted on the community conversation event page where you're registered. And I will share that link in the chat too, right now while I'm thinking of it, just to remind you so that you can remember that. So tomorrow afternoon, we'll have the recording up there. Next, please. I think we're seeing a presenter view here. Oh, okay. This is a fun one here. This is the safe harbor statement. This simply says if we make anything about, we talk about future features or things in the future, that you don't make any purchasing decisions based on that. So if I happen to say that Fusion 360 is going to be able to read your mind and automatically do a model, that would be really cool and helpful, but you can't buy the product based on that wild statement of mine. So simple keeps us out of trouble. Everybody knows. All right, next, please. There we go. Quick introductions. Again, I'm Sean Hurley. I'm Autodesk Community Engagement Manager. I am a geeky technologist located in sunny Bend, Oregon. That is the sunny side of Oregon. Over to you, Praise.
Thank you, Sean. Welcome, everybody, to the webinar. My name is Praise Tom. I work as a technical support specialist for Fusion 360 in Autodesk. So today's session is meant for the people who are new to manufacturing workspace and the person who are new to the machine process and how we have to take it forward. So I'll be guiding through few methods and set up what is the workflow which you will have to follow in setting up the job in CNC Mission, which will help you to understand how to set up your work more precisely and accurately in Fusion 360. So this session is intended for the beginners. So basically, I'll start with Fusion 360 and design and manufacturing workspace, then basic terms in manufacturing. Then we will have a demo simultaneously in the presentation and demo on CNC Mission. So at the end of the session, we will have a Q&A session. If you have any questions, please feel free to post it in the chat. So let's begin. So in any component, it starts with the design. So the design can be used in solid workspace with a sheet metal or surface forming. In manufacturing workspace, we select the toolpath to generate the model, and also we decide the manufacturing strategies for that model to create that model. In post processor tab, we convert all the toolpath into a mission code, that's G code and M code, with the help of the post processor available in the mission. So in CNC mission, we set up the work for the subtractive or additive manufacture. So in subtractive, we remove the material, and in additive manufacture technique, we add the material layer by layer and build the final model. So basically, a CNC mission operates based on the graphing coordinate pairs, which we all did it in our schools. For example, if you say 2, 3 location XY plane, you know how to mark those points in the graph sheet, right? So basically, there are a set of G codes and M codes. Based on that, the mission will operate. And if you give the coordinates, it moves to the respective position. For example, these all are the some of the important code which you should know as a beginner. M06T1 means it's the command for the mission to change the tool to 1. M03S7000 means spindle start in clockwise direction at an RPM of 7000. So M04 is for anti-clockwise direction. Next one is G54 is for the work coordinate system, where we set up the work coordinates for the workpiece. G90 is absolute coordinates. So what it means is it takes all the coordinates with respect to the work coordinate system. G17 is XY plane. G43H1 is the command which we give for the mission for the tool offset value. And M08, it's coolant on. Then we give all XY locations. Based on all these codes, the mission will start moving to the respective X and Y coordinates. As you know, Z is perpendicular to this plane, right? Moving on. So in manufacturing, the basic concept is you should have a stock or workpiece. That means it's a metal piece of metal where you are gonna make the model. So as you see here, this is a 3-axis CNC mission. On the bed, you have X and Y coordinates. So the bed can move in X axis, positive X and negative X, as well as Y. And C is on the spindle head. That's where we attach the tool. This is the controller which we use to control the CNC mission. You can use the jog and control in XYZ directions. Another important thing is all the mission has a default coordinates that's known as mission coordinates. So in work coordinates, what do you mean by work coordinate? The work coordinates is set a reference to the workpiece. Basically in G codes, it starts from G54 to G59. That means G54 is for work coordinate system 1, G55 work coordinate system 2. So all the G codes and M code should be read by the mission with the help of the controller. Each mission has its own controller according to their manufacturer. So as you see here, job 1 is set up for the work coordinate system 1, that's G54. In the command, in the G code, if you call G54, it takes that as your work coordinate system. And if you take WCS2, let's say G55, if you call, it takes that as the reference point. Basically, in a mission, the work coordinate system is used to, we are telling the mission that, yeah, this is the point where you are going to operate, or where you are going to work on all the toolpath, right? So So let's see some of the important basic terms. The first one is tool length offset. As you are aware, we never use only one tool for some operation. It will have a different length as well as different diameter. So each tool has different diameter, so as well as the length. The tool length offset is nothing but the difference from the spindle nose to the tip of the tool, as you see in the figure 1. So you have to define all the tool length offset value before starting the mission, so that each and every time you no need to go and set up the tool offset distance. So there are some methods to use tool offset value. First one is the laser method. So it will have a laser sensor, laser beam coming and measuring what is the length. Next one is the mechanical method, where you use a mechanical device Otis there and touch the tool onto this device and determine what is the length. And next process, you can use a slip gauge or Priston 123 block. It's a predefined size block, and you can jog the machine one toe and understand. The last one is optical sensors you can use and determine what is how far the tool is situated from the spindle nose. Next one is cutter compensation. This is basically the tool diameter, tool length, or tool wear or deflection. If you are undergoing a continuous production process, the tool will get wear after 2 or 3 operation, depends upon the tool. So it's our duty to maintain the precision. You always have to measure the tool diameter, and if there are any changes, you have to compensate that to the machine so that you will be able to produce the accurate components. All right, so as an intro, in Fusion 360, most of you know that it's a cloud-based software. It has integrated CAD, CAM, and CAD, then simulation, generative design, cloud collaboration. Additional capabilities with the extension, you can work with product design, nesting, and fabrication for sheet metal parts. So basically in Fusion 360 Workspace, most of you know, I will quickly go through it. So this is called as data panel, and these are the workspace available. And towards the right, you can see the toolbars. And this is known as browser tab. And on the bottom, you see it's a design timeline. That means if you selected any of the component, you will be able to see what all are the process which we have taken place. So in Fusion 360, all the files will be saved in the cloud. You can create a new project like a folder, and also you can invite the people to your project. So these are the components. There are 2 components. I'm going to save this on the correct location. So it's going to save it as a version number 1. And you can always edit as all other software do. It's a parametric. It will adjust automatically. So you can use the assembly tab to do the connection. Then finally, if you save the component, you can see that it's taking place to version 2. At any point of time, you can go back to the version 1 and see what all are the changes you have made, right? So in manufacturer workspace, as I mentioned, there are set of different tool paths, 2D and 3D tool paths. So these all are some of the important tool paths which we use. In over here, 2D adaptive and pocket operation is generally used for clearing out a large amount of material. It's basically used for roughing process. And contour is for a steep wall, or as you see the structure, you can go for some structure like that for contour operations. In parallel toolpath, it generates the toolpath along the XY axis or any plane. And in spiral, it takes the toolpaths with respect to the center point. And steep and shallow, it's a combination of parallel toolpath as well as a contour toolpath. All right. So let's explore some of the important points which you have to remember while setting up the manufacturer job in Fusion 360. So the first part is you have to decide what is the work coordinate system. Then you have to decide what is the stock. Then you have to create the toolpath. Then you post process the toolpath, whatever generated in Fusion 360. So this is the manufacturer workspace of Fusion 360. It has milling, turning, additive, inspection, and fabrications. So for this part, we are gonna do a milling operation. So the first process is to create a setup, then generate the toolpath. You see the toolpath there. So let me create a new toolpath here. The machine is optional and select the operation type first. So you can define the work coordinate system. Then you can decide what is the model which you are gonna check it. Accessibility analysis is to check whether you are able to access all the area of the tool. So next process is set up the workpiece. So there are different options. You can use fixed or relative, whatever the available standard size of workpiece which you have or the stock you have. The next tab is for naming the program and setting up the work coordinate system. All right. So you can see on the browser tab, there is a setup is created. So the next process is select the toolpath. In toolpath, when you select, you have 4 tabs there. The first tab is for the setting up the selecting the tool. You can filter what type of tool you want. It's from the library. If you don't find the tool, you can customize and add it. And in the geometry tab, where we select the geometry, that means the pocket. So I selected these two. Then in the heights tab, it's control the mission by area. That means you can define how your tool, the material should remove by depth, how much distance, how much stock has to remove. And in the passes tab, it controls what is a type it has to follow, whether it should cut in both the ways or how much is the depth, step over, step down. If you want to finish, you can go with the multiple depths, depends upon your mission. And if you wanted to leave some stock for the roughing operation, you can leave some stocks there. So in linking tab, basically it controls the entry and exit of the toolpath, right? So you can decide how the tool you wanted to approach to the workpiece, whether it's a helix or plunge, all those settings. So I hope you have got a basic idea of manufacture workspace. So let's move on. So we have created the toolpath. You can see the toolpath here with the type of tool which you use and work coordinate system. So in Fusion, we have an option to simulate how the toolpath is generated. You can go to the simulate option and see a visual representation of how the toolpath is generating. So once it's done, you're happy with it, you can post your toolpath into G code and M code. You have to choose a post processor according to your mission. All right, so it's going to create a G code and M code as you see here. So this one we are going to insert into the mission, so the operation will take place. So I repeat, in any manufacturer workspace, first thing is you have to decide what is the work coordinate system so that the machine will understand, okay, this is my work coordinate system. Select the model which we created in 3D design workspace, select the stock available to you, create the toolpath, then post process it. All right, so This is the model which we have manufactured. This is an aerospace component which we did it for a testing purpose before the actual production. So it has two holes with a thread and counter bore. There are a set of slant edges and curved face here. So generally, to finish this part, you need to have a two setups, right? We can use the facing, drilling, tapping, 3D, 2D, all the toolpath to finish this part. So let's see how to set up this first. So I have the components here. I hope you can see it. Yep. So this we have created in CNC machine. So the problem here is to decide which phase we have to cover first, right? So here, if I cover the top phase that's over here, if I cover that first, or if I finish that first in my setup one, you have to flip it over. So we might have a less space to hold this workspace, to hold this workpiece on a vise. So what we decided, the best way to go with it, you have to finish the setup number one first, like this. So we are going to use a profile operation, drilling, and slot operation, or the undercut you can see there. Okay. So once we done that, we will get a output like this. So now we will take this and finish the workpiece in the setup number 2 and finish the job. Okay. So to create this model, we need to have a two setups in 3-axis machine. So here we have a set of operations which we chose according to our mission and the toolpath. There is no hardcore rule that you have to follow only these kind of toolpath to create this model. Of course, it will vary to person and depends upon the mission capabilities as well. So the feeds and speeds is you always have to refer to the standard manual. You can decide. We are not talking anything about that right now in this session. All right. So let's get into the Fusion and see how to set up the job. All right. So the first process, as I mentioned, this is the model. What you see here, it has a slot undercut there, and here we have a threaded hole, and there is a counter bore here. And in manufacture workspace, we have to first create the setup. So to create the setup, just click here and the option here. If you have any model first process, what you will do, you will select a stock. So you have to select a stock first by using fixed or relative size. Then you can decide what type of operation you are going to do. Then you can select what is your work coordinate system. The work coordinate system can be defined based on the workpiece or on the model, wherever you can measure it on the CNC machine. Select the model. And here you can type your program number and the work coordinate system here. All right. So while setting up the workpiece or CNC machine, first thing what you have to do is you have to set up the vise in such a way that it is aligned properly. And then you have to load all the tools which is required and add all the tool parameter, diameter, tool offset. You have to add to the machine. So you will have a set of tool numbers, maybe let's say 10 tools, and corresponding diameter and length you will have to add. Then next process is you have to set up the work coordinate system. As I mentioned, machine has its own default coordinates. So we are telling by defining work coordinate system, machine that this is the work coordinate system where is my job is, the workpiece is located. You have to create the toolpath around that. So for that, you have to use you have to load the stock, then use the edge finder and find the edges use the zero setter to find the height of the length of the tool. So basically, the edge finder is a tool where it's when it runs at uh, mean speed, the bottom portion will be coaxially placed. Once it is touched to any surface, it will move out so that you can take that coordinates and add to the machine. Similarly, dial indicator is to get the reference, datum reference. And in Z0 setter is again, you will take the tool and touch on the Z0 setter, get the reference value. This uh, zero setter has 50 mm height, so it's a non-height, so you can minus what is the actual distance from the machine coordinates to the tool tip and load that to the machine. So let's see the process in detail. So the first one is setting up the voice. So you have to make sure that you can take the dial and fix the voice on the bed and try to align and make sure that the dial is not changing. That means it is horizontal to the machine by using the dial. Next one is the zero setter. To find the tool length offset, you can take the tool, touch on this zero setter. So this zero setter has a 50 mm height, and the machine know where is its bed, and so that it will take the reference from the nose to the tool tip. Similarly, all the tools you will have to do it, and you will have to add to the CNC machine, right? So next one is setting up the work coordinate system. So to setting up the work coordinate system, we use the edge finder. So for that, edge finder is rotating at 7,500 RPM. Once it is touched, you can see that there is a small oscillation here. It's offsetted from its axis. So take that coordinates, and the important points here is you have to find out the center point. So it has a diameter. You have to minus the radius to get exactly the center point, right? You have to minus the radius, so then only you will get the edge of the workpiece. So this is in positive X, and similarly you have to do it on the other side. This is in Y direction. I'm not doing it in X direction because I haven't finished that phase. We will do that little later. So we fixed now Y coordinates. We added the Y coordinates in work coordinate system. Usually in work coordinate system, it's a coordinates. It should have X, Y, Z values. So now let's see how to set up the C values. So to set up the C values, you take the dial gauge and touch on the bed. So take that point and load to the machine, then take up the dial, touch on the top of the workpiece so that you will get the reference to the top. Set that point as your set WCS1, that's G54. All right, moving on. So the next process, once you set up the um, job in the workpiece, the next part you have to do it for the toolpath, generate the toolpath. So let's see how to generate the toolpath for setup one in Fusion 360. So I'm saying it again, this is not the only way to create the toolpath. You can use any type of toolpath to finish this model according to your mission capabilities and tool properties. So this is my work. This is my model and this is my stock. The first process is you gonna finish this. Let me just align it. Yeah, we are going to finish this setup first. That means our work coordinate system is here. The first process is a phasing operation. So all these tool movements have taken from work with respect to the work coordinate system because we are using G90 absolute coordinates. So next process is drilling process. So before you do any drilling process, you have to do a spot drill so that the drilling can happen properly. Then the drilling, then the tapping. Tapping is for threading operation. And then you have a contour roughing, then contour finishing, again, the contour roughing inside pockets, contour finishing here, then the pocket, and there is a undercut here. So we use a contour operation, then finally the chamfer. So in face, a facing toolpath, you don't have much things to select or worry, because since your model is already selected, you just have to select the bottom, set the bottom reference. Bottom reference is nothing but till which point you wanted to cut the material. So you can select what is the more different types. So I chose my model top as bottom reference. That means it's gonna cut till the model top. And in the passes tab, you can choose the operation which you want. So here, since my tool is not carbide, so I have to make sure that the depth of card, the step down should be less. So I just use the minimum multiple depths here. And in the linking tab, how the tool should approach. Then the next operation is drilling. It's a spot drilling here. Okay. So in the spot drilling, what I selected here is the whole face, right? And then the bottom reference I chose as the chamfer diameter. What is the chamfer diameter? Yeah, pretty much that we have to give it as input to create a spot drill. So the first thing what you have to do if you are new to the Fusion and if you are new to the workspace, first thing what you have to do is you just select the face and click OK and see how the toolpath is generating. If it is not according to your need, then you have to come back and see what else you can adjust here. Right, so then the next process is drilling. So here you have a geometry. You have to select the face. In the geometry tab, of course, the tool is default. And select the diameter. If you have multiple holes, you can use the same diameter option so that it's going to select the multiple same diameter at once. You don't need to select one by one. And again here, this is the height tab. That means till what depth your hole has to, the drill bit has to go. Then the cycle operation, whether it is tapping or whether it is drilling. So basically in the drilling workspace, all the methods, all the workspace looks same here. Only thing is the operation, whether it is drilling rapid out or tapping, has to change in the cycle type. So let's get into the PowerPoint and see how the toolpath is generated here. As I mentioned, there are a set of operations you can use here to finish the setup number one. So this is the spot drill, which we have to use initially to make sure that the drill bit is passing through the material properly. The first operation is the spot drill, which we do it on the center point of each the hole before the drill, before the actual drill. And next one is the tapping operation. We use a tap tool and select the hole and use the tapping operations here. All right. And next one is contour operations. So in contour operations, as you know, it's used to finish the wall. So you see the contour operations of internal finish, right? And this is the profile outside. So as I mentioned here, there is no right or wrong way to create there is no hardcore rule to create. See, for example, here I use a face mill to finish the contour operation. It's not necessary you have to use end mill to create the contour operations, right? So it's up to you. So let's see in Fusion 360 what contour operation does. In contour operations, the settings, what you have to do is select the tool which you want and decide the tool has to within the boundary or outside the boundary. So you have different options, bounding box or a selection, whatever. You can choose it according to the model. And also the important step is here to rest machining. So once you enable this, whatever the operation we have finished here will continue from that. All right. And next one is decide the height, how much depth your tool has to go. Then the passes tab, you decide how much should be the tolerance. That depends upon the machine and its accuracy, and the direction type, whether it is a both way or one side. Then how much stock you have to leave in the workpiece. Then this option is for a multi-axis machine. Anyway, it's a 3-axis, so we are not going for it. In linking tab, what is the type of retraction policy? Once it's done a operation, should it come back? How frequently it should come back, so that it will allow some time for the chip and the tool to cool. And lead in and lead out is how the tool should approach to the workpiece. Okay, and that is the roughing operation. Then I use a finishing operations around this model. So what I have done here is I selected an option to avoid touch surface. You have multiple ways to do is I'm just showing you the different ways you can select this, so that what it does is it avoids touching all those surface. It's just go only around that. Or you can even create the sketch and select the geometry. Again, the height tab, it's same. You can decide how much depth you wanted to remove the material. Then in the passes tab, again, it's all repetitive process. You have to click on it and see how the toolpath is generating. If you're happy with it, you can go ahead with that and control the speed. If not, you can go back and edit it here. All right. So let's see in machining, CNC machining. Yeah, so I didn't cover this. Let's see here. In the slot operation, there is a undercut here. So we have actually a 2D slot, but the problem with that is the slot should be perpendicular to the tool. So we can use really this slot over here. So what we use is we use a contour operation with a T slot cutter. So this is the tool. If you don't have the tool in the library, you can go back here, select the tool, and you have an option to edit the tool and create the new tool with, you can change what is the diameter and feed speed data, you can add it here. So I use a T slot cutter here, and the contour selection is here, one edge. And the passes tab, I took this as a selection point. So here you have an option. You can choose select and select the point or edge or face. And accordingly, you can give the offset value from with respect to that. All right, so let's see in mission how it works. So this is a T-slot cutter, which cuts the material. Yep. So basically, this is the operations. We use a contour toolpath here, not the slot. Yep. So the final part of the setup one is to chamfer all the edges. So we can use the chamfer toolpath chamfer tool. Sorry, the chamfer tool to finish the workpiece. For that, you have to define the chamfer width, how much in Fusion 360. So in Fusion screen, you select the geometry first, right? Then decide how much should be your chamfer width. So this is my chamfer offset. So I choose 1 mm because my chamfer is 1 mm. Choose that. It's going to finish the toolpath here. Similarly, for the edges. So choose the edges of the model, give the chamfer offset, it's going to create the toolpath, right? So finally, if you wanted to see the toolpath in the Fusion 360, you have an option to simulate to see how the toolpath is looks like, right? This is pre-drill, drill, then contour operations. Yeah, roughing, finishing. This is the finishing of internal with the end mill, then the contour finish. So to remove this extra material, I just use the chamfer finally. All right, so that's how we finish the first setup for the workpiece. So as an output, you will be able to have, you will get a workpiece, the model like this. Now what we are going to do is we will flip the workpiece and set up the job. Before doing that, you have to define what is the work coordinate system. So for that, what you have to do is take the dial indicator, touch on the reference, go to the workpiece, touch on the bottom surface of the workpiece, or if you are not possible, you can touch it on the soft jaw here. Why we are going with the finish, the bottom surface is because it's already finished. So with respect to that, we are setting the reference. So we fix the Z reference first, and let's do a phasing operations here in the setup two. So I'm doing the phasing operations so that the additional stock will get removed. So the finally, you will get a workpiece something like this. Okay. So on a finished component, we are setting up the work coordinate system again, because it will give you the more accurate result and you will be able to generate the part from here. So here, the first process, as you know already, X and Y coordinates. Take the edge finder, touch on the Y's or the workpiece where it is offset from the axis, plot that point minus the radius of the diameter of the edge finder. Similarly, for x-axis, you can repeat the same process, all right, which will add all x, y, and c value for WCS2. As if you call in the program G55, it's gonna choose WCS2, right? This is the setup 2. Uh, we we are going to hold the part on the finished surface, because um, because you have to go for the other setup now, right? So let's see in Fusion 360 how do we set up this. The process is same. um, so my aim here is for you to understand what is the basic setup which you can do it in the setting up the workpiece. For sure you are not going to use the same model, so there is no much point of explaining you each and every point in the tool paths in each setup, because you have to practice and get it. So what I'm showing here is what I have done it for this tool path. So let's take the face, take out this, then use the pocket, then a finishing operations here. So it's going to finish the part like this. Then the flat toolpath is to finish the flat surface, then the pocket operation to finish this area, and the contour operation to finish the wall. And finally, the parallel toolpath for these surface, and steep and shallow for this curved surface, right? So important, what is the change here is in the setup, the stock you have to choose from preceding setup. So if you choose this option, what it does is whatever the stock remaining after the setup number 1 will be taking it forward. Okay. And you have to enable the continuous machining to continue from that part. So that is the only difference here, which I set it in the setup number 2. And next one is work coordinate system. As I mentioned, we are taking work coordinate system to the finished area of the workpiece, so that you will be able to get the model properly rather just going with any other workspace. So the phasing operation, there is select the tool. You no need to select the geometry because by default the model is selected. Go to the passes, go to the height tab and decide how much you wanted to clear the material. So over here in the selection process, as I mentioned, you can use the selection, and I chose this as a selection point. It's a plane. So what it does, it select the bottom as that much. And if you wanted to adjust the bottom height, let's say I want 10 mm from that selected point, selected plane. So it's gonna adjust it, right? Yep. Again, if you need the multiple depth of, if you are using the carbide tools, maybe you can go do in 1 or 2 go. So here depends on my tool. I choose 5 as a step down, then again linking tab here, same. Then the pocket operation. Again, here you can select this chain. Okay, so as I mentioned, you can create a sketch and select the chain in the model. If you see the model here, yep. So you can see a set of sketches here, which you can select. This is for the pocket operation. You can select this as your machining boundary, so that the tool path will create there. And this option will keep the tool inside the boundary, and center on the boundary means the axis of the tool will be along this boundary. Outside means the tool is going to cut outside the part. Okay, right. So then again, the pocket operation, 3D pocket operation to finish the components here. Again, you can go with adaptive clearing. You can go with pocket clearing. It's up to you. Even you can go with 2D adaptive clearing. But in 2D adaptive clearing, you won't be able to finish this slant phase. So that time again, it's take more time. So it's all depends upon you. You can choose any tool path as a beginner. You can choose any tool path and see how it behaves and how it's generate the tool path. Then you try to modify, simulate and see whether it's cutting all the areas. Keep modifying the geometries. All right, so let's see some of the operations which we have done it in Mission. So this is the part which we get after the phasing operation. Then we have to do the pocket operation to finish the part. This is the flat toolpath here. And this is the pocket operation. And finally, to finish with, we have to use a parallel toolpath, which we haven't covered yet. So in parallel toolpath, as I mentioned, it will create the toolpath parallel to the any plane. So select this plane. Let's say you can select this geometry. It's going to create the toolpath around here and decide what height you wanted to cut the model. Then decide whether you have to leave the stock. This is a finishing operation which I'm doing. So I don't want to do any stock left there. Similarly, for the other side, again, you go to the chain, select the model, select the tool. Yep. So for finishing operation, you have to make sure you have to choose the ball and mill. So then only you will get the proper finish. So to roughing operation, you can use phasing and end mill. And if you have any fillet in the model, you can use bull nose end mill. All right. So, oh yeah. So here in the passes tab, let's say I want my parallel toolpath to be generated along this edge. So you have an option to select the toolpath and click OK. You will get the toolpath generated along that side. And finally, the steep and shallow. So in steep and shallow, in steep area, it follows the contour operation, and shallow area, it follows the parallel toolpath. So here you have to select the chain. For example, if you select this, you get only this surface. If you wanted to add this, what you have to do is just click and hold here, and you will get an option to add here. So this is for closed one. This is for the open loop. So it's a closed one. So what I'm going to do, I'm selecting this area, right? You can alternatively use the Alt key and add the geometry, right? And define the height, how much height you wanted to cut. In the passes tab, use the operation type, whether it is parallel or whether it is scallop. Again, so finally, you can just see the operations here in the mission. This is the parallel pass. We are using the ball and mill to finish this edge. And finally, we are using the steep and shallow toolpath for this curved edges. All right. So moving on we are towards the end of the session, and please feel free to post your questions in the chat box. So we can also use mission simulation in Fusion 360 for generating the toolpath. So whatever the toolpath which we have generated in Fusion 360, you can choose the mission to that and see whether is there any clash, collide, whether tool or tool holder collides with any of the part of the mission. So basically, this is intended for a 5-axis mission. The mission simulation we can use. We can use the stock avoidance setups in the 5-axis mission. So that time it will be very useful. So let's see how we select the mission simulation in Fusion 360. I'll give you a brief overview about it. And with that, we will end today's session. So as you see my screen, do you remember when we created the setup, we had an option to select the mission. We haven't selected that. So once you click on this option to select the mission, yep, sorry, select the mission. There are default simulation ready file missions available in the Fusion 360 library, mission library. So once you click on simulation ready, the mission which is available for simulation, it will be listed. You can choose according to your manufacturer, or if you are not able to find the manufacturer, you see whether it's the configuration of the mission is matches with the mission which we are working with. And also in the mission, if you have the mission models, you can configure the mission kinematics. Uh, that means you can change X, Y value and define what is the limit. You can create your own mission in mission simulation. So another option, what we haven't discussed in setup tab is, you see there is a fixture. So if you would like to add the fixture and see how the model is going to manufacture actually, to create the toolpath, the fixture or mission is not required. You just have to have a model, select the stock and create. But if you want to have an overview, a visual representation, and in the mission, how it is going to simulate, or how the workpiece is going to sit in the mission, you can enable this fixture option here. Okay, so I just downloaded a voice from our manager Lars. So that wise I have uploaded in the design workspace. Okay, this is the voice and this is my model. So I used move option to align, make sure that the move or some align option to make sure that the workpiece is fitted properly here. Okay, then I'm going to the manufacture workspace. I have created all the toolpath. At the end, I edited the setup, go to the mission, selected the mission, so which will import the mission here. All right. So there is no much things to worry about when you import the mission. If it is a simulation ready file, you just have to select the mission and select the fixture. You will be able to simulate the workpiece. So over here, you have an option, simulate with mission. Okay. Yeah, it's taking some time. Yeah. Yeah. You can use the simulate with mission and you can see what is the toolpath. This is the toolpath what we have created with the model. Only thing is we just added a mission to the simulation to better view. All right, so that's all from my end. I hope as a beginner you are able to understand some of the basic concept. And if you have any questions, I believe the Shan is answering all the questions in the chat box. And if you have any, um, please feel free to ask. Thank you.
Let's get on to the slides here. I'm going to give some helpful resources for everybody. I also gave the Fusion Insiders, which is where you can get in and talk with the team and get early builds and new features for testing. So it's always neat to see that. There should be one with community resource links. Praise.
Yep.
Is it? There we go. Yep. All right. So some of the community resource links I gave you is the forums. It's a great place to ask your questions. There's some great Fusion 360 experts in there. The community groups, the Community Voices blog, that is community members like yourself writing on different tips, tricks, workflows, all that kind of stuff. The community journal, that's the community team, the student group hub, community conversations that you have here. So go and look at the calendar. We'll be adding a bunch more by the end of the week. And many of those are going to be Fusion 360, our Twitter, our Facebook, all that. But stay connected in the Autodesk community. Praise, thank you very much. Do we have any other questions in here? You're welcome, Richard. Just thanking me for the links. There's a lot of good resources out there. That's how you learn a lot of these products, is you lean on the rest of the community. Timothy, there's what are some good resources to obtain post-processor files for defining machines? Praise, do you know that? I know they share a lot of those in the forum groups.
Mm-hmm. Can you say it again, the questions?
He asked, what are some good resources to obtain post-processor files and defining machines? Yep.
So basically in Fusion 360, we have a set of post-processor. So if you are not finding them, it's recommend for you to reach to the resellers. If not, you pause your requirements in the community webinar. We have a team of technical consultant dedicated only for this post-processor options. So they will be taking it up, and make sure that you will get more recommendation in the forum post, so that the team will get more attention to that post, and in future we will be making it. Yep.
Absolutely. Stephen pointed out, yeah, the large library of posts in Fusion 360. lot of resources there. I gave a knowledge base document as well. So anything else? If not, we will let you go enjoy your evening and praise, enjoy your morning.
Yep.
I'm gonna enjoy my evening here.
Yep.
So,
Sure. Thank you, everyone. Thank you,
thank you,
Shan.
everybody.
Yep.